the wireless network initially started off with mobile voice, and mobile voice, as you might also already know, it's a symmetric data transmission, wherein the uplink and the downlink typically has the same kind of a rate of data. And for this reason, why most of the allocations on the wireless spectrum has always been a paired spectrum, and it was always an full duplex frequency FDD domain that we normally talk about. It's a frequency division and duplex. Um, and much of the focus initially has been in terms of how well can I give a single service of voice to as much users as possible. This was actually an evolution from the fixed telephony network that had existed in the past for many tens of years before this. And subsequently, we moved on to mobile telephony. If I may use this pointer. So from 2G, we directly went on to 3G spectrum on 3G services, which was basically derived out of WCDMA and TD-SCDMA. These were two different technologies or protocol sets that we defined for 3G services. 3G services was one of the first technology wherein we could actually have circuit switched and packet switched differentiation. And we were able to use circuit switch for voice and packet switch for the actual data. And this was almost the turn of the millennia, and you were able to see data traffic slowly getting on from the mobile devices. So it was just kind of starting to engage in terms of certain services which required data. Services were more or less voice and a little bit of a browsing. And of course, you had at that time a new technology called MMS, which was multimedia messaging service, which was slightly an enhanced version of what a short message service was able to offer at that time. This went on for a few years, and then we had the LTE, which was a long-term evolution. The idea was primarily to come up with a harmonized technology which could take care of all the flavors of 3G. Just to go back, 3G was actually having an FDD and TDD variant of it. TDD was primarily China and associated markets, and rest of the markets were predominantly FDD domain 3G services. So LTE, when it came in, it was actually looked at as a umbrella technology which could actually make an evolution path for all the existing 2G, 3G services. And one interesting fact also is that if you look at the kind of spectrum bandwidths that 4G could support, it always had certain spectrum bandwidths which were specific to the previous technology that used to use. So it used to have a 1.4 megahertz spectrum, which was a CDMA evolution path. There was one 3 megahertz and 5 megahertz spectrum, which was closer towards interoperating with the 2G and 3G spectrum, or 2G and 3G networks. So LTE was one of the first technology wherein we were seeing the harmonious way to evolve. When we did that, we had problems with respect to coverage holes, wherein certain pockets were not being addressed properly for the services being offered. And hence there was a focus on the heterogeneous networks, wherein you could actually put in a small cell. We had lots of variants before this. We had something called unlicensed mobile access, which was UMA, which was in 2006. And subsequently, when LTE moved into a certain level of maturity, we had LTE small cells as well evolving. LTE also had an unlicensed variant, which was called a licensed, unlicensed Wi-Fi. Along with unlicensed Wi-Fi, you had the licensed wireless access, wherein you could actually have one of the existing spectrum as the anchor layer, and then you could use the existing unlicensed spectrum for dedicated quality of service-based services. Now, Around this time, only the smartphone revolution also happened, which actually triggered the overall data growth in the system. Subsequent developments have been on the network side, wherein you were able to use um, cloudification of your existing network nodes. By cloudification, I mean earlier there were dedicated hardware which were proprietary to each and every vendors, and they used to have a software running on it, which was RTOS based software with some certain applications and protocol stack on top. Now the network function virtualization and the telco cloud, this actually moved things away from the proprietary hardware so that it could be built on top of an standard x86 hardware, and you could actually put just the software on top from any vendor, and then you could actually build a system on top. So this went on for a while and subsequently paved way to 5G services, which was primarily a technology wherein you could think beyond a simple data bearer or a pipe in terms of use cases. So 5G services was one of the first technology wherein you could actually envisage lots of use cases beyond a normal discussion about throughput and certain services that you have had in past. Now, if you look at the past few years or past couple of decades, what exactly has changed, right? So before 5G, pretty much the solutions were technology driven. So you would always talk about 2G, 3G, 4G as a technology. But when it actually comes to 5G, we know that the 5G's bandwidth requirement is in such a way that you are able to provide a uniform layer wherein you could actually provide throughput anywhere and everywhere in the network. And we are now looking at what do we do on top of it. So it is more of a business driven discussion on the solutions rather than a technology driven solution. And one of the driver, which was previously just the discussion about bandwidth or a consumer, now it is industry. So now each and every enterprise is now interested in finding out this new wireless platform of 5G, and they are looking at how much SLA can be offered with the existing infrastructure that an operator or an infrastructure provider is providing. The architecture was earlier a hugely centralized architecture, wherein if you remember how 3G and 2G used to function, you used to have a controller and then a BTS at the bottom, which could be controlled by this BSC. Whereas in case of 4G and 5G, we have completely removed the controller functionality towards core and also towards the BTS, so that the decentralization could actually happen, and you could actually with more flexibility you can deploy your network. In terms of standards, if you look at earlier, we used to always look forward to having a standard first and then develop the stack. Now in 5G and beyond, we expect that it might be the other way, wherein you would have them either follow or go hand in hand. So you know a problem is coming up, you know how to solve it, you immediately try to push it into the standard, get the software done, and then you deploy it on the network. It would be that fast. And in terms of flexibility, 5G and beyond gives a large flexibility because it's software defined. Whereas in case of 4G and even 3G, it was always you had someone to go there and provision your hardware and then energize that radio or core network component to make sure that coverage is given in those particular areas. And the last one is the innovation speed. If you look at the innovation speed, earlier it used to be to think about a new service that you want to offer. It used to take a lot of time in terms of deciding how the things have to be envisaged. Here now, with the new concept of slicing, you would be able to think about new applications and new services on top with number of innovations per day or per hour, per hour is a slight exaggeration, but then it's possible because of the flexibility that it offers. We look at the compared to how it has been in the past, now going forward in 5G network, the applications redefine the network requirements. As I told in the first slide, with 5G, we know that the network is able to have the needed bandwidth. Now the question is, how do I reconfigure to make sure that the services on top could be provided with minimal interruptions? So any questions there? Okay. So on the left, if you look at this particular graph, it actually maps the latency with the bandwidth, and it actually puts in the requirement of certain use cases that has been highlighted in terms of how much bandwidth probably it would be requiring and how much would be the latency or a permissible latency that it could work with. So you see that there are lots of Internet of Things related use cases. There are lots of video related use cases that are possible with the latency in terms of higher milliseconds and seconds, right? And also with respect to the bandwidth requirement, which is quite high. All this is possible with your 4G network as well. So what is it that is going to drive the new set of use cases and new set of requirements is primarily the one that are on the right hand side, wherein the latency needs to be very low and the bandwidth needs to be quite high, right? And in this particular segment, which is kind of encircled, is primarily where we see more thought had to be given in terms of how to redesign our network, existing 4G network. So just to give a perspective, if you have looked at the XR as a use case in a little bit detail, or you are able to perceive that particular use case, you know that there is a headset that a person is wearing, and the headset, when it is moved gyroscopically, left or right, up or down, it needs to send some signal to the other endpoint in terms of the movement, and the user needs to visualize based on this movement what is the new video content that, or video or audio content that is now relevant for that particular spot that he is viewing, right? So if you look at on the right hand side, so it is more like I am actually a UE, which is the user equipment or a mobile device or a device. Now, this could be a haptic device, or it could be a gyroscopic or a headset. Now, this movement that I'm talking about, left, right, up and down, that needs to be communicated to the radio network, to the core network, to an application software, and then it has to be responded back within a span of, say, 20 milliseconds. 20 milliseconds is typically a number which we call a motion to photon. It's kind of a latency number that we say, with which you don't get into a motion sickness, in the sense that it's almost like you get into a virtual set, you want an immersive experience. If you're not getting the immersive experience, you will start feeling a little bit of a sickness in terms of reality getting getting into a breaking point, in the sense that you will feel that, okay, I'm looking at something, but I know that it is not real. So immersive experience primarily means that you are into a headset and you feel that the virtual world is a real world, right? So to make sure that happens, you need to have it within a few tens of milliseconds, this whole latency requirement. And that indicates that I need to reconfigure my network, right? So there are applications now that are coming up. Bandwidth probably might not be an issue, because that is more or less based on your backhaul throughput capabilities, and you have an air interface. You can assign so much of spectrum. But then the next one is to how do I connect my network equipment's application server so that the overall round trip time is reduced, right?
Sorry,
Rama?
I'm interrupting you here. Mitra, Shiva here, is right? If you could kindly go back to the previous slide. Yeah, the previous slide.
Yeah.
Yes. Could you kindly help me understand this pitch dark green graph is there, right? Exactly at 10 milliseconds latency, there is a vertical shift in the bandwidth straight away from 100 kbps to roughly about 100 mbps. The dark green graph what you are showing. In any particular scenario, use case, under what circumstance it takes that shift? Such a huge shift it is from 100 kbps to 100 mbps at the same latency point of 10 milliseconds. What triggers it actually?
So this is one point. This is the other point that it is getting connected to. So this is primarily a case of a cloud-assisted driving. So these were all the use cases that that has been envisaged during the initial part of 5G network research,
Yeah.
wherein you could actually expect that you could have a cloud component very near to your roadway network, and then you could actually devise certain way of collision avoidance and collision detection, those kind of use cases. So that is a cloud assisted driving, and you could actually do an autonomous vehicle motion wherein you could actually need to have lots of information that needs to be going here
Yeah.
and there in terms of
Yes.
so that is one of the major difference that being shown here, right? So
Yeah.
there is no
Got it.
yeah.
Thank you. Thank you so much.
Yeah. So this is the other view in terms of how a 5G network deployment happens. So it is, so we normally have this tendency to look at, okay, I have a new network or new technology. Is it going to completely wipe out the existing network? The always the answer is no, because we do not know what a new technology is going to offer and how it's going to be taken up. But it definitely offers lots of potential, and hence we think that even if there is a movement from the previous technology to the new technology, it would be a gradual decline in terms of the previous one. There would be a churn happening in terms of how the users who are existing in the previous technology needs to be slowly encouraged to move to the new technology, and then you shut down the old technology so that the operational cost can be profitably maintained. So this particular slide is just kind of explaining why or what 5G offers. So it is more of an augmenting layer on top of the existing networks, and it actually addresses the existing set of subscriber use cases, and of course augments with new set of services on top. Now, one of the first thing that we have seen in the past is primarily the capacity expansion and traffic offloading as the key use cases that it has been targeted for. In the sense that you take up any operator in India, most of their 4G networks are getting onto the choking point. Specifically, Geo happens to be one which is 4G centric to start with initially, and it did not have the 2G spectrum as such. So for it, it was 5G was a very elegant movement because it knew that it had started with the 4G network, and then it was evolving onto a 5G network. For the rest of the other things, they already have the 2G for voice. So there was always a decision point in terms of how do you want to go for a 5G as a service? Should we just use it for a certain as a capacity layer for certain area, or should we go in for a full-fledged umbrella kind of a network or a wide coverage network? So these are all the points that CSPs from a strategy angle they look at, and then in terms of how they would want, because it all involves an investment, approximate investment as well. So other topic is in terms of the superiority in user experience. So if I use the existing network and then just augment it with 5G, do I give the user experience that is needed? Or otherwise, I need to completely go in for a 5G overhaul. And what if the 5G uptake is not proper? 5G uptake, by 5G uptake, I mean that if the user devices are not available in the market, what do I do? So that if I have my 4G network, at least I would be able to fall back, right? So all these kind of questions that they are the areas wherein the operators do spend a lot of thoughts on, and then they kind of make sure that the user experience is not reduced when they do these kind of transitions. Typically, so of course the audience, in the audience we would have lots of variations in terms of how people perceive this. So just to be on the same page, so when you actually deploy a network, you have certain areas called an urban sector, there are suburban sector, there are rural sectors. In urban sector, there are expected to be lots of big high rises, and hence the coverage of the layers need to be horizontal as well as vertical. Whereas in case of town coverage or village coverage, it is more on a horizontal coverage that we normally look at. And of course, in terms of how many layers do I need to put, also comes into play when you actually look out for suburban and rural. In urban, capacity would be peaked, in the sense that you would always see a lot of users using the new technology because of the economy in that particular sector. Of course, you need to understand also the fact that there would be lots of coverage gaps in these kind of areas, and hence you need to figure out how to address those capacity coverage gaps and capacity requirements as well. Right. So so this is a very high recap on the 5G technology. In case you have seen this already, it's a recap. Otherwise, it's just an extra. It's an information that we wanted to give. Next, we look at the 5G global and India-specific trends. So 5G uptake has been one of the fastest that we have seen in the last couple of decades, that we have seen for the last different technologies. Primarily because 4G was already a data-centric technology, and with that we were able to understand, or we were able to get mature enough in terms of how the data is handled. We have seen areas wherein the downlink has been quite high. There are cases wherein the coverage holes have occurred. So we are prepared in terms of how things have happened. The physical layer pretty much is same as for 5G, is same as 4G or similar to 4G, except for the subcarrier spacing. So we know how things are going to happen, what are the different problems that we're going to get in, and hence there is a definitive increase in the speed at which we have been able to accept 5G as a technology. And if you look at the global operator space, 310 operators as of Q4 2023, which is last year's numbers, which is still 9 months before, but still is a good indication that 5G is not something new. It has already reached certain level of acceptance over the world. There are lots of 5G devices already announced, and we haven't actually talked about the SA, NSA part, which we will be coming to that slightly later. But kindly note this particular point, that many of these devices are already SA capable, or a standalone 5G network capable. And there is a significance here, and I'll probably let you know in subsequent slides. And also in terms of the 5G connections, as of 2023, it was 1.6 billion, and it is now nearing about 2.1 billion by end of this year. It's a forecasted numbers. Now, one other trend that I wanted to share with you was the decline in the 2G and 3G network deployment, or the subscription as of now. This is the total number of connection that is being shown in terms of 2G services as a percentage of the overall mobile connections. So from 2022, if you look at till 2030, there is a steady decline in terms of the share. Similar trend primarily seen in 3G also, and and the reason is that most of the operators are now looking at offering whatever they were able to offer with 2G and 3G network with the new technology that they are deploying. So either these operators have already deployed 4G or they're looking forward to 5G already. And this list of operators gives you an indication of when they are shutting down their respective older technology. Right, and this actually covers only from 2023, and there are lots of networks that have already been shut down prior to this. So we looked at the overall 5G growth. We also looked at the decline in 2G and 3G services. Now, how does the ecosystem, the device ecosystem, flourishing in terms of 5G? So on the left, you see that it's a graph indicating the band, the 5G band that the devices that have been announced till now, the 5G devices that have been announced till now, they support. So we see that N78, which is the 3.5 gigahertz band of India, uh, and N41, which is the 2600 megahertz band of India. So these are one of the most popular bands for the 5G network, right? And apart from this, N1 is the 2100 megahertz, the traditional 3G band. N28 is the 700 megahertz band, which is India specific. N3, N5, and N8 are the 1800 megahertz, um, 850 megahertz, and 900 megahertz bands. Right, so all the bands, and of course N40 is again another band that RGO and Bharti Airtel they have. So all these bands, that India specific bands, have one of the most popular bands in the device ecosystem. So, and hence from India market perspective, maybe there is not much of a worry in terms of how the device ecosystem would be able to support my network whenever I deploy. Right, so this is still a global trend. We'll come to the India specific trend slightly later. So on the right, we would see that the 5G devices that have been announced, how many of them are SA specific devices, and this is a correlation with the previous graph that we saw in the previous page. We'll come to what an SA and NSA is, but both are primarily the 5G technology in terms of how it is deployed. And also in terms of the devices that have been commercially available, though the majority ones are phones, there are also lots of devices which are on the industrial CPE or a fixed wireless access CPE domain. And there are also few which are MiFi kind of a device. And there are few which are modules. Modules are something that could be fit into any of the devices based on the need, and it could also be used for IoT kind of a use case. So what the primary message here is that devices does not mean a mobile device. It could actually be in any form and factor, but then eventually it would be used for 5G as a connectivity modem. So we come to the India specific trend. So so the left hand side graph shows the overall BTS that we have been able to deploy. We as in India as a country, we have been able to deploy across multiple operators. So there's been a humongous growth in the way the network BTS has been commissioned in the last 1 year, from March 5 to March 31st, 2024. And you would also see if there is any report in terms of how India has fared in terms of the mean downlink speed. It has gone up multiple places ahead, right? And the only reason why it has actually jumped so much in terms of mean downlink speed is because the 5G has been deployed at such a fast pace. The overall downlink experience has been quite good now, right? So that is one of the very interesting fact that we saw for India, that the rate of deployment was quite high, and there's been an improvement in the downlink mean downlink speed, and it is getting at par with multiple leading markets in the world. On the right hand side, it's a mobile subscription share by technology, and we see, like we saw in the previous set of slides, that the 2G and 3G is kind of declining, and 4G and 5G are primarily taking the overall space going forward from 2024, and eventually it would be ruled by 5G devices by 2029, the end of this decade. And another interesting fact in the last 1 year is that the amount of 5G share in terms of the device support has significantly increased by around 10%. So earlier it was 5G capable devices were close to 25% of the devices that were existing in India. Now it is close to 38 to 40%. So this gives you a kind of a good feeling in terms of how, if you're going to deploy a 5G network, there are enough takers, and hence my investment, as in the operator's investment, does not go waste, right?
Sorry, just a quick question from the
Yeah.
previous slide.
Yeah.
Sitaram. The green patch again talks about mobile subscription share by technology, which I understand is for 5G. Top right, yeah.
Yeah,
This is
yeah,
the graph.
yeah.
So are these green percentages, which predominantly shows the 5G mobile subscribers, are they migrated subscribers, or willingly they are coming forward to avail the 5G subscription? Are they migrated, or
So this
are
is
they
this is more or less a forecast.
willingly they have come forward? Yeah.
So this is more or less a
The
forecast.
green percentage, which is gradually increasing, which I presume that these are 5G subscription
Correct, correct,
percentage,
correct.
right?
So you're asking whether there is a
Are
willingness to move to
migrated
5G,
migrated
or otherwise it is a, okay. So
migrated from the previous technology to 5G, or
um, we need to look at this report. This is
like say
coming
if
Ombia report.
yeah,
We need to specifically look
yeah,
at that. I can take a look at it and get back on that. But my guess
sure,
normally is that most
sure, sure.
most of the subscription, if it is not monetized specifically, what the normally what the normally what the operator would do is go ahead and um, exchange your existing 4G subscription with a 5G SIM, and they might count
That's
the
a
5G.
migration. Yeah,
Yeah, so
yeah,
they might count that as a 5G SIM. This primarily indicates
yeah,
that you are capable to do that service. Assuming that your device is
yeah.
capable, you are now capable of
Capable
providing that
enough. Yeah.
service. Yeah. So this does not relate
Correct.
to the
And also the
monetary what.
device need to be comfortable. The EU has to be comfortable with that.
Correct, correct. Yes, correct, correct, correct.
Thank you. That answers my question.
So the next slide is primarily on Nokia's MBIT report. This has lots of information. I would encourage you to just go to Nokia website and search for Nokia MBIT report or MBIT index. It is MBIT. And this is the 11th edition that we have in 2024. Previous 10 editions, you can actually have a look at the detailed report, and you will see lots of information about how the traffic has been changing, or how the uptake has been taking over the years, in terms of how certain type of traffic have are more preferred in terms of the users. So all those details have been quite much analyzed and given to you as a report. Every year we, by around February of a year, we publish this report. I would encourage you to have a look at it. But having said that, so 2024 MBIT report primarily aligns with the global trend that 5G and 4G traffic contributions, if you look at the 5G contribution has actually increased. And this was one of the reason why there is an increased mean downlink speed increment. And you also see that there is a solid growth in mobile data traffic across all circles in India, right? Primarily with in the metros also reaching 20% of the 5G traffic share. There are significant amount of close to 17% active 4G devices which are 5G capable. And with a 5G subscription migration, you would be able to kind of think about monetizing this a little bit more from an operator perspective. One other trend, of course, is quite intuitive, is that whenever an operator deploys a 5G fixed wireless access, we tend to see an increased data traffic increment. And this is quite intuitive because by fixed wireless access, I mean something like an air fiber or a CPE that you can fix outside your house, and it directly communicates with the cellular tower, and then it gives you a Wi-Fi access to the inside of the house. And when you do that, you can have more than one device associated with it, and each one of them, assuming that it is full, it is having a very good speed. So eventually, without even knowing, you are actually incrementing the speed of that particular subscription of 5G by 2 to 2.5 times from an operator perspective. So this is a very intuitive trend that we saw, and it is quite happening even now. The other trend also is that the 5G users on an average are consuming more data compared to 4G users, and this is predominantly the mobile 5G users. This is primarily because of the user experiences being better. You tend to go for a higher picture quality or video quality in terms of when you're on the move. And the bottom graph is just showing you the device ecosystem view, which we have already covered in the past. So are we on time? Can it still take 15 minutes more? Okay, so next we'll just have a look at the spectrum view.
Yeah. You please go ahead.
Sir. Okay, sir. Thank you, sir. Thanks. So next we look at the 5G spectrum and network deployment, which is the crux of the basic discussion point. So from a spectrum perspective, if you look at these are primarily the spectrum bands that are in use in India for across different operators. So 700 is the B28, 850, 900 is the B5, B8, 1800 megahertz is B3. Then there is N1, band 40, band 41, which is 23 and 2600 megahertz. N78 is 3.5 gigahertz. And then we have this N258 or in something in the 200 something range, which is the 26-28 gigahertz band. That's for millimeter wave. Traditionally, from a basic concept perspective, the lower that you are on the band spectrum, the cell size or the deployment cell size would be quite big, in the sense that you would be able to cover more area geographically for the same power that you radiate. But then when you go up the frequency spectrum, the cell size would be much smaller, which basically means that it will be good enough for hotspots. But then from the spectrum availability perspective, lower the spectrum, the lesser the availability of spectrum. When you actually go higher the frequency band, you will have a higher amount of availability of spectrum, because it is not being used by anybody. So the next column actually talks about where you would use or what would you use it for. So sub 1 gigahertz by rule of thumb is a coverage layer for any operator. It is an FDD spectrum, and you get close to 5 to 10 megahertz per operator. That's how it has been. In the 1 gigahertz to 2 gigahertz band, or even 2.5 up to 3 gigahertz band, it is a macro capacity, in the sense that you can actually deploy in your regular tower grid, and then you can actually give also a capacity, a certain amount of capacity to the cellular users. When you go beyond this, it is a hotspot capacity, because you do not have the coverage, and hence you need to only limit it to certain geographical area, and then you can give higher capacity in those kind of geographical areas. So till this point of time, 700 was recently auctioned, but before that we only had 850, 900 megahertz, 1800 for the 2G spectrum initially, CDMA and 2G spectrum, and then 2100 megahertz came in for 3G. So as of now, these four were the FDD bands that could be used for your 2G and 3G services, which have slowly, the operators have started migrating to 4G network, right? 2010 or 2011, approximately in that span, and of course 2600 megahertz in close to 2015, we had around close to 20 to 40 megahertz band allocated to operators, which was a TDD spectrum for LTE. So by last decade, we primarily had these 4 bands allocated for macro capacity, and then we were offering services for over multiple circles in India. Now, recently 3.5 gigahertz and 700 megahertz have been taken, and along with that, millimeter wave spectrum has also been taken. All these are new spectrum bands, and operators feel that they could actually go in for 5G directly. So if you see on the spectrum chart here, so 700 megahertz could be a good layer for an operator who wants to have a coverage on 5G. You could go ahead and deploy your existing 900, 1800, and 2100 megahertz. You can migrate from LTE to 5G and also use that as a coverage layer, right? When you do all these things, then whatever has been the allocation for 3.5 gigahertz, which is the primary capacity layer of 5G that we have in India, we can use this particular spectrum for your downlink capacity. So all these are coverage. Coverage, when I say coverage, it is primarily the uplink, right? Because the in whole of this space, whatever is your BTS power of transmission, the user equipment or the mobile's transmission power is limited, and it is 23 dBm. So much of the coverage for a given frequency band is defined by how much soever it can actually transmit or radiate. So for all these reasons, you have to make sure that you always have a smaller or a lower frequency layer wherein you could actually provide coverage to the users, and on the downlink, you could actually use one of these 3.5 gigahertz or 26 or 2300 megahertz. So all these layers, you can use it for the downlink as a capacity layer. So from a use case perspective, wherever you could actually have higher spectrum availability, there you could actually focus for the higher data rates and fixed wireless access capacity. Wherever you had, say, around 30-40 megahertz, and you still had existing dependency on LTE, then you have to chunk out maybe 100, probably 10 or 20 megahertz from that 40 megahertz, and then you can migrate to 5G and then start giving slight low traffic area 5G with the existing equipment itself. So you don't have to buy a new equipment here. You can just migrate your existing equipment and then start deploying 5G. And for the lower ones, it's quite difficult because you have an existing 2G and 2G and LTE subscribers pretty much in different markets. So operators would be quite hesitant to go for migration here. But then, of course, 700 megahertz, if you have, or any new spectrum that comes in the new auction that we have subsequently, you could actually start thinking about using that for 5G altogether. You need to understand one thing, that wherever you have services of voice, you need to make sure that the coverage is ubiquitous, in the sense that every nook and corner, you have that particular frequency layer to be active, so that if you are putting voice in that particular layer, you do not get into a drop call. Right, so that is one of the key requirement as a KPI that everybody monitors. So, so if you are looking at voice over NR, so earlier if you had LT, you had voice over LT, and when you actually migrate to 5G, you can go for voice over NR. When you go in for voice over NR, you need to make sure that you have at least one sub 1 gigahertz layer to make sure that you have ubiquitous coverage, and then have a good layer for that service to be offered. So we then come to the 5G network architecture option. So the left-hand one is the traditional LTE. It's called option 1. Actually, if you remember, or if you have gone through this already, when 5G was getting initially discussed, lots of operators had different thoughts in terms of how they would want to migrate onto 5G. So there are different options that they were being that were being considered in terms of how a particular operator would want to migrate to 5G. Eventually, this started posing problems for the equipment vendors in terms of what options do we eventually have to support, because there is so much of deviations, interoperability, all those things need to be tested. Thus, eventually, what was standardized in 3GPP were option 3X and option 2. So option 3X is non-standalone, which basically means that with my existing core infrastructure, with existing radio infrastructure, with a slight add-on on the radio, I would be able to support 5G. Whereas 5G standalone indicated that I would have a dedicated network, irrespective of what my 4G status is. I would have a dedicated layer only for 5G. Right. So these were the two launch options that were offered for different operators on mutual consensus. Right. But having said that, there was also an evolution option or a migration option for future, wherein instead, say for instance, on the left-hand side, option 3X, you see that EPC is still the core network. So assuming that on the once the 5G is offered, the subscription has gone up, and the current existing EPC is not able to hold on to the existing subscriptions, thus they require a new migration on the core network. They could go for a 5G core network and then move all their existing LTE infrastructure also onto 5G. So they could transition from 3X to 7X or from 3X to 4. Both options are possible. Right? For a 5G standalone option, he already has this. Now, like say for instance, you have RGO, Reliance Jio, then they already have a core network. They have a 5G infrastructure. If they want to migrate from their existing EPC, they could also go in for from 2 to 7X if they need to, or they could also maintain this as separate layers. What do we gain out of 5G standalone are primarily certain radio performance benefits. And then if you look at very specifically, slicing is more improved when you actually go towards standalone. It is not that it requires standalone. Slicing can be done even with 4G or a NSA 5G, but it's slightly better off in case we go in for 5G with a standalone option. So this is so we looked at the architectural complexity. There is also another complexity in terms of how a particular network node could be cut in terms of disaggregation, in the sense if you want to split the software from the hardware, right? So primarily the cloudification, right? So this primarily is a slide that is focusing on that. On the left, you have certain variants of the way the network could be cut. So first two are primarily, if you look at, there is no virtualization here. It is primarily DU and CU, centralized and distributed unit. But these could actually be a software entity that could co-locate at the cell site along with RU, which is the classical deployment. And then you could also kind of move this towards far edge, wherein you could actually pile up lots of baseband units and then deploy front haul networks and then RUs at specific locations, and hence provide a 5G network. All these are connected to core through backhaul. Now, this is the existing 5G deployment model. Now you could also have virtualization of this, wherein each of these units are now prefixed with V, which is virtualized. So the virtualization, which basically means it's a cloud component, could now be distributed on the run based on the requirement that I have. So I could have the VDU or the virtualized DU quite closer to the cell site, or I could also, and I could actually have virtualized CU much closer to the core. Right? This could be one deployment model, or otherwise I could actually do even the virtualization of DU after I virtualize, I could actually keep it at far edge, or I could also keep certain components of core unit at the far edge. And here I could also co-locate the core, right? So these are the different combinations of deployments that are now possible based on the split of DU and CU in 5G. But this also opens up lots of complexity with respect to interoperating it with the existing network of 4G and also the 2G network. So pros and cons, they do have their own weightage, and depending on how easy or difficult it is for the operator, they transition towards a certain deployment option. Now, so we actually talked about network slicing in the slide previous to that. So it is not that network slicing requires a certain a 5G option of deployment. Network slicing is just a conceptual case which indicates that based on need, the operator is able to slice his entire network in terms of quality of service and also in terms of how it could be deployed with certain SLAs, right? Now, I could do this even in 4G network. Only thing is, in 4G network, it needs to be manually sliced, and it actually requires a multiple touch point. In the sense, I need to go and configure at multiple places with certain configuration, and I would be able to create or demarcate certain traffic in my existing 4G network. When I go in from 4G network to 5G network, it could be an NSA, the option 3X. I still could make sure that the existing 4G network related network slicing could be migrated onto NSA with slight additional flexibilities. But when we actually go into the 5G standalone case, the visibility of the slice is from the UE till the core network, inclusive of RAN. Everybody knows this concept of slice. And once that is available, I'm able to kind of seamlessly stitch a network end to end. So that is an automation that I'm able to do based on this one ID that is now completely transparent across all the nodes in the network of 5G, right? So 5G, so network slicing is a very good way of, or it's an economic way of delivering diverse customer needs and use cases. And it could be done in 4G, but it is just that it is much more enhanced in case of 5G network. And there are lots of business aspects and also technical aspects. In technical aspects, primarily in terms of how can you segregate lots of slices for different geographic areas and different services, and also for different kind of users. And you could also do it in a very fast way in a 5G standalone network, right? And it could actually work irrespective of whether it's a cloud or a classical deployment. So, okay, so with that, where do we go from here? So we actually right now are in 2024, wherein we just about released. So this is more of a roadmap picture for standardization of 3GPP, but this has quite a bit of information to gather in terms of solutions as well. So release 18 is what we recently in June 2024 released. We had an ASN freeze around that time. So release 18 happened to be the first release of 5G Advanced. So we have already a standardized first cut of 5G Advanced in place. So the solutions would start getting developed in the next 9 months to 1 year, and then subsequently the rollout would start. There are lots of study items already in pipeline for the release 19 and release 20. Release 20 is typically be the time when 6G study would also start. But meantime, you would also have maturity of the existing 5G Advanced use cases and study items. So we expect that 5G Advanced, at least in the markets wherein 5G had been launched a couple of years back, they would start accepting 5G Advanced already. And then from India perspective, we expect that there would be some push, at least certain kind of use cases should start seeing some light of day in the coming years. In terms of the trends that we see in terms of 5G advanced, so right now we are on the leftmost path, wherein we are still looking at the subscription conversion from 4G to 5G. We are looking at the unlimited 5G data package, and then of course speed-based data package. There is a considerable look at how to monetize the 5G network as of now. And one of the easiest way to look at is primarily looking at enterprise use cases for network slicing. And then, of course, you already have seen the 5G air fiber and those kind of cases, which actually gives you a direct access and utilization of your 5G spectrum, and a good opportunity for the operators as well to monetize the existing spend that they have done on the spectrum. 5G advanced would be able to give you more emerging use cases wherein you would have XR based experience, but this would be still slightly outdoor event based services. And then you would also have certain bundling for home entertainment using slicing. Subsequently, going forward, you would also see the non-terrestrial networks maturity, but we still look at that coming up slightly late in India. Of course, the unmanned aircraft vehicles and these kind of use cases would still take a little bit of time in terms of how, because there are a lot of regulation involvement as well in terms of how it can happen in multiple countries. So this would still is something that is on a back burner, but then it can definitely come in certain countries already if the regulations are quite fast getting accepted. So key takeaways, paradigm shift we see from the past. There is also which is allowing lots of use cases to be deployed or at least envisioned. Apart from speed, latency is now a very interesting point for differentiation because of the way the XR and other use cases are going to evolve. 5G has seen the fastest uptake compared to other mobile technologies, and 2G and 3G trend is on the decline as of now. And then we also saw that multiple spectrum and architectural options that are existing in the 5G, and this actually still gives us certain guidelines on what are the launch options and what are the evolution options for the operators. Slicing we see as a very good key enabler for handling multiple use cases, primarily because of the flexibility it offers in terms of cutting the network into very definitive SLAs. And then we do see 5G evolving to advanced 5G and then shaping an ecosystem. So yeah, so with that, I would stop here. And if there are questions, I would be happy to answer them.
Thank you very much for giving this opportunity to speak here. I'm kind of echoing. So, okay. So, I'll just quickly introduce Signaltron. Signaltron is an Indian OEM. We're focusing on products for wired and wireless technologies, and especially doing systems for the RAN side of 4G, 5G networks. And we have some indigenous base stations that have been deployed under BSNL project, as well as for some strategic requirements. As I introduce the products from Signaltron, I have to spend a little time on an effort on the chipset that we did at Signal Chip. Signal Chip is a company founded in 2010, which focuses on semiconductor chip development. It's a fabless company working on chips for these domains, and has come up with the first chips for telecom from India. And in Signaltron in 2019, we started this company to focus on the complete end systems using these chips that we have built earlier in Signal Chip. Okay. So as I mentioned, in 2019, we came up with this chipset called Agumbe, which is the first 4G, 5G chipset to come out of India. And these have gone through multiple level of testing and have got deployed into systems. And I'll just quickly touch upon the chips that we have done, and then go into the systems that these are used into. Okay. So the Agumbe family of chips has 4 chips that are available. The first one, the flagship chip that we started working on way back in 2010 was this SCBM 3412, which is a single chip SoC for a complete base station in a single chip. Okay. So it kind of targets the ultra compact and cost sensitive small cells. And then we have the baseband SoC, which is SCBM 3404, which does dual carrier MIMO 4x4 baseband. And then there are 2 RF chips, 3402, which is a 4G RF chip, and 4502, which is a 5G FR1 RF chip. So these represent the first and the only chips from India for 4G, 5G, and all these are currently working in system. And we are working on further chips for 5G, which I'll briefly touch upon a little later. But from the previous some of the previous speakers also, you would have seen 5G is actually an evolution over 4G in terms of the general RAN structure. So the chipsets that we have built for 4G are being as relevant for 5G. I'll just introduce this SCBM 3412, which we call the flagship chip in this slide. So we have this kind of a bird's eye view of this chip. On the left side at the top, you actually see the complete analog RF subsystem, which is integrated into this chip. So you see the complete receiver chain, which is which contains the RF transmitter, RF receiver, LNA, mixer, the low pass filters, the ADCs, and on the transmit side you see the DACs, LPFs, again the mixers, and a reasonably mid power PA for an indoor type of an application. This could be coupled with an external power amplifier to do high ranges and larger capacities, which I will show how we have done that earlier. This chip also integrates an auxiliary receiver to enable things like SON and NMM, where NMM is these are the cases where the base station needs to understand what is the surrounding environment around it, and has to work like a UE for like a handset for a little time. So this section pretty much contains everything that is typically seen in a transceiver chip in a traditional sense. But this chip does not stop there. It integrates the rest of the baseband also into the same silicon, and you see a whole bunch of advanced signal processing blocks which are sitting right next to this high performance analog baseband. And these do things like DPD, crest factor reduction, and of course MIMO and MMSC, MIMO TX and MMSC receiver. And we also have a whole bunch of communication physical layer components inside the chip, which do the 4G, 5G baseband, and there we in fact even support 3G when we started way back in 2010. That was still relevant, and there is a communication protocol stack that runs on a quad-core processor, which is Linux capable, and does all the layer 2, layer 3 functionality of this. We also have something called a Marut networking engine, which runs along with this, and also has we have an internal processor, our own RISC called Avarta. Avarta it stands for cycles. Or if any of you is musically oriented, then you'll know the tala that they put is an Avartas. So that's how we named that processor. So this chip contains 14 processor cores, including this Avarta as well. Many of these Avartas. These put together give a very high performance, high performance and very optimal implementation of communication protocol layer as well as the backhaul stack like the TCP/IP, UDP, whatever you are running on the stack. So they all work in unison with the Linux processor that is running there. And we have the advanced security engines here. And then there's a whole bunch of high-speed interfaces for bringing this data out and in the MIA and RGMIA. This actually is probably, I mean, if signal gets in over here and gets out on the air over here, on this Ethernet is where the backhaul connection comes. So this whole kind of thing happen here. We also integrate NAVIC into the same chip, and we can also do a Wi-Fi listen for some modes like where you are trying to do LBA and things like that, LAA and things like that. So this is a chipset which is and if you look at the RF chipset, it kind of if you break out that RF portion from the previous block diagram and put it separately with a little bit more additional capability on the bandwidth and the filtering capabilities, that is what the SCRF 4502, which is the first 5G chip from India, which has come out. So this chip is a 2x2 chip right now, and again can do all 5G FR1 signal bands, and it can do both TDD and FDD as well. Okay. And within this chip, the advanced signal processing is also put along with this, so that it takes away the burden of doing high-speed compute, which are kind of tied to the RF system, or the RU in the 5G parlance, and you can put that in the in this particular side of the system. Okay. So having these are the 4 chips which I spoke about, what is there on the left side of the screen here. And then we have already taped out an advanced 2x2 RF chip, which is already out of the fab, and we are currently testing this, and this is looking good to go. And we have 3 more chips which are coming up from Signal Chip. One is the 5G RF for massive MIMO, which is apologies for the typo over there, which is for this device gives you 8x8 RF for all the FR1 bands again, and has more advanced bandwidth capabilities than what was there, and higher capability in terms of DPD as well. And then we have the baseband chip taking from the 4G baseband. We have 2 chips coming out here. One is a high capability DUCU chip where you could run the distributed unit on this optimal chipset, and then also integrated G-Node B for a single box kind of a solution with compact footprint. So these are the chipsets which are currently being worked upon by us, and hopefully soon we will see these also in the market. This gives a quick view of the integrated G-Node B chip. I just mentioned to you a few minutes back that from a from a signal processing RAN concept wise, the modules look fairly similar. There is a scalability, there is a higher, the data rates are scaled up to a significantly higher level, and also you need more performance on each of these processors and also the packet processing engine. So this is what is currently in progress as well. So we are almost through with most of these modules, and we should be getting out with this chip as well soon. So so much so from signal chip, which has been done in the last few years. So where are these chips now going in? How do you how are we actually using them and actually taking it to the final system? Development of RAN is a fairly RAN equipment is a fairly large effort, and as we design these chips, we had to completely develop the systems also around them, so that the chips were validated at the system level. So Signaltron took off as an effort to take this and finally get indigenous systems out in the market being used by people. So we have a few systems which are already built on this, and here is a list of those. So we have a scalable BBU DU, which does both 4G baseband as well as 5G DU in a single box. And this box is basically, this is kind of catered towards macro deployments, where you can insert a few cards into these, and each card can do 3 sectors of deployment for 4G and a little lesser for 5G. But the entire box itself can do multiple cells of 4G or 5G, the baseband portion. Then it pairs with what you see here, the fourth block over here, which is a RRH/RU. RRH is the 4G radio, RU is the 5G radio. So we have this 4x4 40 watts per antenna kind of a RRH/RU. So these two can complete a macro deployment for you. Okay. Then we have this integrated eNode B, which is a single box complete 4G base station. This is the base station which is actually deployed in currently in BSNL pilots. About 45 cells are currently radiating with these boxes. Then we have another box which is called the network in a box, where the RAN and the core network components both are in a single box. These are mainly used for strategic requirements and also for things like disaster management, where the connectivity to a core is not guaranteed, but you want an immediate deployment of a single cell where people can communicate amongst themselves. In the it is like a single unit private network kind of a thing, right? So that's what the NIB is doing, network in a box. So so we have these also currently produced and deployed. I will show you a little later. Indian Army is using them. So these are the few of these systems, and then we have this indoor and outdoor small cell systems. We have an extremely compact small cell femtocell kind of a system, which is probably slightly bigger than a credit card kind of a form factor. So these are for deployments in indoor situations, or probably in dense deployments like malls and offices and probably stadiums. So that is the box we have. With the SCRF 4502, we have developed the GNODB system, the complete integrated 5G base station system. And these are also currently being deployed as, in fact, in ISC Art Park, this particular system is there today as a 5G base station for the 5G labs. So these are the systems that are kind of done. And as I mentioned to you, we are working on other systems which are CUDU for 5G and massive MIMO RU. So we are working on as of now 32 cross 32, 8 cross 8 and 32 cross 32 systems for RU, which again contain our RF chipset. So these are the kind of systems that as Signaltron we have are working in and getting them out in a short future. So the from a ORAN compliance and ORAN perspective, we have both our platforms, they do target both the architectures, especially coming from a chipset perspective. We would like it to be usable under any architecture, so it can have been made versatile. And in case of the system itself, we have ORAN compliant ORUs, and our CUDOs are ORAN compliant. So that is how the systems are coming in. So I think probably have got the flavor of what I'm trying to say. So we have targeted to develop the complete stack from here. So kind of we call it Swadeshi in heart, soul, mind, and body. So right from the chipset, these systems are built here, and then the entire system itself now, which integrates a lot of complex modules for baseband and RF processing, even the efficient power supply units, the RF front end. We even build our own duplexers in these systems. So this is being targeted to be built here, and also the software stack running on these are Indian currently. So it's sort of an entire end-to-end ownership in terms of technology, so that we can develop these optimal systems and take it across to Indian customers as well as the rest of the world. So that's the thought process. So we started a while back trying to kind of build the silicon core inside it, and then slowly we have added the outer layers all the way up to the equipment, and now we have complete end-to-end systems which are indigenized, and these are now being taken out to deployment. So having built all this, where exactly have this been currently deployed? What's the status of that? We have a few deployments. It's been a long development cycle, but we have now started deploying these. So the initial success has been with, of course, with the government organizations. We have BSNL via ITI, and where we have done 44 cells of 4G Node B. These are integrated with the BSNL's 4G network, which is coming up now, and people are doing calls with this. Then we have, of course, Indian Army, as I told you. We are working with CDOT for the 5G RU development, for their 5G RU development, and also the 5G labs. I will briefly touch upon these in the next few slides. So the BSNL USOF pilots, these are 44 cells running the systems in rural Karnataka. The aim has been to provide last mile connectivity. So in 2 years back, we did the first deployment of this, and a call was made from Pragati Maidan to Hirekatigenhalli in rural Bangalore. It's about 70-80 kilometers from here. And that's the first time an Indian chip got deployed into a base station and started radiating signals. So that was that was the start of it. And earlier this year, we have completed deployment of all the cells. And recently, we completed delivering 20 NIBs, the network in a box, to Eastern Command, and it went to rigorous testing from them. And then the induction was completed recently, and these boxes have been actually deployed in the border area already, and are working well over there. So this again was a first in terms of Atmanirbharta goals of the Indian Army as well, where right from the chip to the entire system was was built in India and provided to them. So these were our successes on that. And more close to where we are talking now, there are this 100 5G labs which earlier in an earlier session Sheila man talked about, was speaking about. So this 5G labs, 25 of these labs in South India are being provided by Signaltron, and they run on our 5G G-Node B, which I showed you earlier. And these labs, I'll just take a couple of minutes to explain what they do. But they are mainly to promote the use cases with 5G. So it integrates base station, a core. There is an edge. There's a MEC server. Then we have IoT gateways. We have AR, VR headsets. We have cameras. We have drones. We have CPEs. Apart from the standard 5G data, voice, video services going on phones. So all these applications are enabled in this particular 5G lab kind of a system, which are being deployed in 100 labs all across the country, and 25 are being done by us. And so this is some interesting thing that you will see in the next few months happening across in the colleges, where students and other industry partners can come and use these labs to develop and test their 5G applications or systems or any of their solutions that they are doing. So this again, of course, features our 5G G-Node B, which is currently sitting there. We have outdoor versions of these also coming up right now, which very soon will be available. This one is in the lab environment. So with this kind of product portfolio, right from the chipset level till the system, we have been attempting to indigenize and make products from India for India and for the rest of the world. So those are the offerings and the roadmaps of Signaltron and SignalChip, which I wanted to bring in front of you all. So with that, this one, let me, I don't have much more to speak and don't want to hold you at the end of the day as well. So I will stop my presentation there and open for any questions.
Himanshu, Sheila here. First of all, please accept my sincere apologies at the beginning of this session. I'm extremely sorry about that. Then I have few words to convey to the audience here. In fact, I'm particularly very proud to talk about Himanshu Kasnis. We all need to be very proud about the work he and his team are doing in SignalChip and Signaltron. It was great to hear your story at SignalChip and Signaltron, Himanshu.
Thank you.
Yeah, we have one of their systems here installed in IISc Art Park. And in fact, next week, DOT is conducting a 2-day hackathon for 5G and 6G, and that hackathon will be conducted on this system which is here. And in the first presentation where I gave an introduction about the wired and wireless technology COE here at Art Park, if you all recall, the first picture that was there was for the Signaltron solution that is part of the DOT's 100 5G testbed labs. One of that is here. It's open for all innovators, startups, and researchers to come and try it out. Everybody is welcome to do that. And there is a particular reason why I'm so very proud about talking about Himanshu and what he and his team have accomplished. Himanshu and I were colleagues in one of our earlier companies. So for me, that makes it extra special to talk about him. Always very proud, Himanshu, of what you have been accomplishing.
Thanks a lot.
Yeah, just for information, those who do not already know, before founding SignalChip, Himanshu has had industry experience in Texas Instruments and EPM systems in physical layer VLSI design. and had the recognition of member group technical staff at Texas Instruments and senior member technical staff at EPM Systems. And as we heard so far from him, at Signal Chip Innovations, they have many firsts in the country to their credit. And we wish all the very best going forward. We hope all your products get flooded all across India and rest of the world. All the very best. And we look forward to working very closely with you, your systems, utilizing it, making everybody in our ecosystem use your system here extensively. Thank you for taking time to be part of this workshop.
Sure.
Yeah. I think now we can move on to the questions. There were some questions in the chat box, Himanshu. Would you like us to read it out?
Yeah, I'm seeing the chat box. I think there are probably not many questions.
Yeah,
the questions were very limited because the extent of information was very, very huge. So that's why I was completely speechless. Straight away, I jumped onto collaboration, Mr. Ivanshu. Truly proud of you, as ma'am told, Sheila ma'am told. Very, very proud of you. And I would definitely, because I have a couple of projects in pipeline from European region. So definitely, I would like to collaborate with you. And work
Sure, we will get in touch with you, Shiv Prasad. You're at Telco Sol, I think. Yeah. And Sheila ma'am has the phone number and.
Sure, I'll get.
Yes.
I'll get those details from Sheila.
Yeah. We'll share with you, Shiv Prasad.
Thank you, ma'am.
Sure.
I have a question.
Yes, sir.
What is the CMOS technology node on which your chips are designed?
Typically, we don't go out spelling the technology node. We work on different chips, work all the way from 28 to 65 now, nanometer. But that's not typically published. So we do have some at 25, so 28 and some at 65. Yeah.
Thank you.
I mean, just to put a little bit of perspective to that, sir, the thought process with which we come in the VLSI design is that there is a lot of optimization left out in the design, and there is a rush to go down the nanometer race. Okay, so being an Indian company, we had to utilize a lot of design techniques so that you don't need to go down the nanometer race. Because going down the nanometer race means your price of first chip production is very, very high, and which kind of makes people not try doing chips. Because if just to realize your chip, you have to raise a few millions of dollars. It's not that easy, especially that day when we started 2010. If you look at that. However, we had this USP was that we do this DSP and networking processing at a significantly higher level of design optimization. This is the USP with which Signal Chip in fact started. So you could do what is needed from a performance perspective for the system at staying a couple of nodes behind in some manner. Okay? So that is the idea that we used so that we could sell this idea of making a chip from India, that to something of this complexity, which includes everything that we read in our communication and signal processing and maybe even VLSI course. So that's the perspective. So it's the better question to ask is what's the speed that your chip gives in terms of data rate, what's the bandwidth that the RF works, what's the power that it takes. I mean, these are the things ultimately which are critical, which is where there's a background for my answer in some manner.
Excellent. No, I really appreciate that. I'm just curious to know where Agumbe comes in.
I see. I think Agumbe, of course, is a beautiful location in Western Ghats. And if you see many of the chips across the world, they are named, the code names are all typically beautiful places in the countries where they are made. We have Interlaken from somewhere and those kind of chipsets, Skylight. So, I mean, we had a small internal competition to choose the name for the company and for the chipset. And we felt Agumbe was an apt one coming out of Bangalore and close by is in Karnataka. This beautiful place is there. So we kept the name Agumbe for that. The next chipset, in fact, sir, is called Belur, which is coming out now. The 5G chipsets that I showed you, they're all called Belur because they epitomize the height of architecture and engineering a while back that we had here. So that's the inspiration.
Very nice. Thank you. Are there any other questions?
No question, but just another statement. Himanshu, your talk, I'm sure, has inspired each one here in this session. Thanks once again for that.
Thanks a lot for the opportunity as well. And yeah, thank you very much.
Thank you, Himanshu.
So if there are no further questions, Mr. Kasmis, I'm sorry about the way I prematurely ended the session. I'm sorry about that.
Okay. No, I think just because it was in the next page.
That's what happened. Sorry about that. So that brings us to the end of today's talks. And tomorrow we have a slew of industry talks and other talks. So we assemble again at 10 tomorrow. And I hope all of you participate in that and also invite your colleagues to participate in that. Thank you very much and see you all tomorrow. Thank you.
Thank you, Mr. Shivashankar, for managing the sessions. Thank you, everybody. Have a good day. See you all tomorrow again. Bye.
Thank you.